This year, our capstone team set out to upgrade Hart's subscale rocket motor by replacing bonded joints with a bolt-on design. The old rocket motor was fairly basic, containing a carbon fiber tube epoxied with aluminum end caps. Our design looked to improve upon this by bolting the end caps to the tube. In the new design, there are two distinct changes. Firstly, the retainer ring at the back, 2 in the picture, does not use a snap ring like the previous design. It is instead held together by the bolts. These bolts go through the end cap and tube and connect to the retainer ring. Secondly, we were concerned with the tube losing pressure, so for the front end cap, it is held through compression, meaning the bolts do not go through the tube but are tightened to add compression. Once we finished our design, we had to make it. Firstly, we started with the retainer ring. We machined the aluminum down to fit into the tube. This required hours of machining on the lathe to the desired size. Once that size was achieved, we machined grooves into the part for the O-rings. One problem we came across was tapping the holes. It was important to not over-tap, as we did that on our first attempt and had to redo the entire part. Hours of time wasted. Our final 3 aluminum parts contain the retainer ring, the back end cap, and the front end cap with a groove for the snap ring. This snap ring is important because in the case of overpressure, it will snap off rather than the pressure building in the tube and exploding. This might be exciting, but not the most optimal scenario. Then we had to mix the rocket fuel. This part was exciting but also tedious. We mixed chemicals, waited for it to mix, then put it into a vacuum and waited some more. Once finished, we had 3 tubes of rocket fuel that would be sanded down to fit inside the tube. But before we can launch, we need to hydrostatic test our tube. To do this, we needed to seal off both sides of the tube, preventing any leakage, then fill the tube with water and connect it to a grease gun. The grease gun will pump grease into the tube, tracking the pressure. We were targeting a pressure of 300 to 400 psi. Next, we mount the motor on Hart's test stand for static test fire. Stay tuned for that. Thanks to Hart, OSU School of MIME, and Graph Machine Shop for support.